Hello, today we'll be talking about the Vieta's formulas and how to use them to solve some problems. So first let's talk about what do the Vieta's formulas allow you to do. So they basically determine a relationship between the polynomial's coefficients and a polynomial's roots. So to get right into the Vieta's formulas, let's start with the Vieta's formulas for a quadratic equation, as these are the most simple. So as you know from school, the quadratic equation is any polynomial with the form x squared plus bx plus c. So I will not derive these here. However, if this equation has two roots, distinct p and q, such that when p and q are plugged in for x to make the equation equal to 0, then p plus q will equal negative b over a, and pq will equal c over a. And those are the Vieta's formulas for a quadratic equation. Let's look at how you can apply the Vieta's equations by applying it to a sample problem. So this was taken from the AMC test. So here we see it says let a and b be the roots of the equation x squared minus mx plus 2 equals 0. So let's first start out with this portion of the problem. So we have this equation x squared minus mx plus 2 equals 0, and we have two roots a and b. Now what do we know about these roots? Well, we know that to add them, a plus b is going to equal m over 1, because here we have b, which is negative m, and a, which is just 1, because it's 1 times x. So this is just m. We don't know what m is, so we don't know what this sum is. However, ab we do know, because this equation is plus 2. So 2 is c. So the product will be c over a, which would be 2 over 1 equal to 2. And we will use this fact to continue solving this problem. So we have another equation, x squared minus px plus q equals 0. And for this equation, we have two roots as well. However, these roots are a plus 1 over b and b plus 1 over a. Now, using the same logic as above, we can figure out how they are related, because we are trying to figure out what q is. So we want to figure out how q is related to these roots, as we know that ab equals 2. So why don't we try using our formula again and try to find the product. So the product of a plus 1 over b and b plus 1 over c, b plus 1 over a, sorry. This will be c over a. So now what is c and what is a? So c here is q and a is just 1, correct? So this will just equal q over 1 equals q. So now to solve our problem, we just need to figure out what this product equals. So let's use FOIL here. So when we FOIL and multiply these two binomials, we have ab plus a times 1 over a, which is just 1, plus b, 1 over b times b, which is just 1, plus 1 over b times 1 over a, which is 1 over ab. So this is also equivalent to ab plus 2 plus 1 over ab. Now we know that this expression here is equivalent to q. So once we evaluate what the value of this expression is, we will find the answer to our question. So if you remember from our original or first quadratic equation, we figured out the product of the roots, and the roots were a and b. So ab would be the product of the roots. We come up here, we figured out that ab is actually equivalent to 2. So if we use substitution here of ab equivalent to 2, so we substitute 2 for ab, so we get 2, so ab is 2, plus 2, plus 1 over, now ab is the denominator, and that's equivalent to 2, so that would be 2, which is equivalent to 4 and a half. We simplify this, is equivalent to 9 halves. And there you go, that's your answer. Thank you.